Hey, good morning, it's Luke Wright, 1184930 for MTR 1201. So we're going to step through the motors module assessment. It'll take no more than 5 minutes. So last video, precursor to this one, we went through the different componentries of Millie's flying fish. And now in this one, we're going to go through actually controlling the servo. So as a reference point, so we understand what servo we're talking about, again, the tech specs are, we're using a 9-gram VTech servo. The product number is FS90MR. For reference, it's got 180 degrees that it can move, and at peak torque, it makes 1.8 kilograms per centimeter at 6 volts. Now, next to this, we're going to talk about how we achieved zero or finding zero for the servo, and then after that, we're going to be testing it using some code that we've put through the Arduino, 5 different reference points, using the same testing metrics as test 1. Okay, so achieving zero with the servo. I'm going to pop up on the screen right here, a little screenshot of the code we ran. And essentially what that does, once it's loaded to the Arduino and it physically gets sent to the system to run through, it changes the servo's location or degree based on where the servo believes that true zero is, right? Now, we use 90 degrees because obviously a servo can't go past zero into the negatives. So you need to give it relative, which we gave it 90. So then we can use that 90 degree angle as the zero, if you will, for when we ran the test. So from there, once we ran that code that was mentioned on the screen, we then unbolted the fin from the servo and then put it where we assumed true zero was, or 90 degrees for the testing purposes, and then reattached it. So to ensure some fairness, again, from test design in video 1, the reason why we opted for plexiglass is to show an extended protractor that wouldn't be available if we just used a handheld one. So for testing references, we're using -80, -45, -22, +22, and +45. We could have used zero as technically it's a degree, but I wanted some better quantitative data to really assess off. So for this test, I'll be holding the nose, as it says in the assessment paper, that the fish's body will stay stationary. I'll run through 2 full cycles or loops of the code, and then we'll assess the findings. So through that testing phase, you would have observed 2 different things, one being a -45 and the other at +22 degrees. So firstly, when commanded through code to have the fin angle at -45, you'd see it was actually more at -60. I'll let you go back and replay that. So there's 2 things it could be, either a positional tolerance within the servo itself or a calibration error. More than likely it's calibration with these cheap servos. It can get fixed though with calibrating and further fault finding and testing, just recalibrating it within code. But we didn't want to change it here because we wanted to display a fair test. It's an easy fix. Secondly, +22 degrees, because it doesn't shake at +45, you'd be able to fault find and isolate it to +22. Now with that, it could be 3 different things. Linkage with the load at +22, unlikely. Slight voltage dips, unlikely again because there's no other voltage dips at any other degree. And lastly, a servo dead spot and it's fighting for recorrections in the angle, which is pretty likely with these cheap servos again. And likely what we would see is once you change the code for it to be an angle of +21 or +23, you wouldn't get the shaking anymore because it wouldn't have to fight for any recorrections. All right, thanks for taking the time to look through that. It was a fun one. I look forward to seeing you in the next one.